Well, hi, good morning, and thanks so much for joining me here in my shop for another day at trying to improve this little transistor radio and make it work a little better. That was 7 capacitors changed out, electrolytic capacitors changed out. And today, first thing, I'm going to target one key component, which is probably not a problem, but it's so easy to change it, I should really do it at this point. Now, the problem with the radio is it seems to be receiving okay, but the sound is still a little hashy. It just doesn't sound quite as clear as it should. So what I want to do is I want to listen to the radio play. I'm going to feed a special signal through it so we can kind of hear how it sounds. Then I'm going to change the one part, and then we're going to hear how it sounds, again using the signal generator, and we'll see if it sounds any better. And I'm actually using 2 signal generators here to do this. So this guy's producing the RF radio wave, if you like, that the radio is going to tune in. And then what's going to come out of the speaker is coming actually from this guy up here. That is producing a sweep tone that's sweeping from somewhere around 100 hertz up to somewhere around 9 kilohertz, something like that. Whoosh, whoosh, like that. So you'll hear that in a moment. In order to hear what it really sounds like, I brought a little tiny radio in here. I'm going to be doing a video on this radio at some point in the near future, but for now we're just going to use this as a monitor in here to hear what's actually coming out of this arrangement. Let's do that right now. Get the output from the signal generator. Just going to clip it on the antenna here. There we are. Okay, so now we're going to listen to this on this radio. I'll just leave this going over here. Get this radio turned on. Did you hear the whine come out of this radio? We're hearing that radio, not this one. So what's happening is the local oscillator in this radio is affecting this other radio. That's what's happening there. Okay, let's move the tone over here and hear what it sounds like on this radio. Quite a bit in there. So to my ear, the lower sounds are distorted badly, and the upper sounds not so much, but it's hard to hear distortion in high frequencies, very high frequencies. So the part I want to change out is the diode rectifier that's in here, the diode detector. Let me take the power off. Okay, so the diode is a little tiny part sitting right here. The little tiny black part there. I have no reason to think there's really anything wrong with it. I think diodes are pretty darn rugged, I believe, but I'm sure I can find a good replacement for it. We should look on the schematic here and see what it says. Maybe it names the type. Oh, there's two diodes. Oh, hold the fort. Everybody hold the fort. There's two diodes. This is the one I want to go after. This one looks like it must be involved in the biasing of these two transistors here. Well, it could be a problem too if for some reason this isn't producing the proper forward drop, which I think is what they intended to do. You know, you could have bad biasing in here, which would give some kind of distortion. Not quite what we're hearing though. I think it would be a much sharper distortion, like cutoff type stuff. This one is the one that's recovering the audio from the RF signal. This is really the one I want to go at. D1. D1. There we are. D2 is says varistors. Oh, that's interesting. D2 varistors. IT51. D1 diodo. IT23G. Well, if I've got the wrong diode here, let's see, do I? So this is right up in the radio part of the radio. So I'll bet you it is this one. This one is closer to the output transistors. Wow. Okay, a little hard to see, but let's get the close-up camera going here. Just see here. More light. So this is the one I believe. Here we are. Is the radio. This one here. The other one. It's tricky to see, but right up under that first transistor, there's a little black thing sitting near the two resistors there, and it looks like a flat disc. That's probably the varistor. Okay, so this is the one we want to go at. I've got the number there. I'm going to see if I can find out a little more about the actual component. I have to find a replacement in my stuff here. Well, I found something quite interesting to look at here on the internet. These are early Japanese diodes found in SONY equipment. I believe that's what these are. The one that's in here, according to the information, is the 1T23G. 1T23. Well, it doesn't look anything like these. 1T24. Very distinct look to them. Where's the 2033? Here we are. 1T23G. 1958. Yeah, did I say something stupid about this being 1971? No, this radio is really old. It's not 71, Jim. It's 19. It's definitely 58. Well, I didn't see anything in the radio that looks like that. It sure. Let's go a little further, just in case something funny goes on with the numbers. Looks more like this. Come in all kinds of shapes. He's saying this is one too? Of this sort. Just looking at all the different. Oh my gosh, look at this thing. Still in the package, I guess, is the idea here. Magnetodiode. Magnetodiode. I can't say it. Magnet diode. I never heard of that. Never heard of it. Well, okay, so I'm going to look in the radio for this guy here, 23, this one. It's a very unusual ends out here, very unusual, strange color. It says Sony right on it, 1T23G. Okay, let's look the radio over here for a brown component like that. So this is what I think it is. You know, I'm going to change the focus here on the camera so I can get it much closer here. So just bear with me for a moment while I do that. I have to bring up the dialog box for that camera. Okay, here we go. Zoom in real close. Well, I'm pretty sure that's a diode there. I can't read any of it. We'll leave it alone for now, just in case there's another one in here that I didn't see. Looking for the brown thing. Huh? Whoa. Hang on. What are these? Wait a minute. I thought I changed all the electrolytic capacitors. What's this? There's two here. How did I miss them? Well, two more capacitors to do. We got to do these first before anything else. How did I miss those? I don't get it. Because on the sheet here, I counted them. See, I put a red dot beside the ones I thought were... Well, I missed that one right there. Okay, a couple more. Oh, that's good news. Maybe that's really the cause of the problem. Let's go again. Let's keep looking for the diode, though. Well, okay, found something. You go fishing for one kind of fish, get something else. I don't see anything. Those are. Okay, hold on a second. This one I replaced. Isn't that my replacement there? Yeah, that's my replacement. Duh. This is the only one I missed. Okay, I missed one. I'm gonna start replacing the ones I replaced. That'd be good. So this is all kind of the audio end of things here. I can't imagine the diode would be down this area. It's gonna be up here. It's gonna be at the end of the radio string, which I'm gonna guess is this end down here, and there it is, sitting right there. Where? Right there. Well, let's get this one out and take a look at it and see if we can't. Yeah, we get. Oh no! We're doing this. We're doing this first. Get rid of this guy. Right. Okay. I think I've said it before. If there's a wrong way to do something, I can find it, including missing things, I guess. Okay. Wow. Let's put another red dot on it. So I did this to make sure I wouldn't miss any. It's 6 volts sitting right there. How can I miss it? Did I miss any others? No, I did not. Oh well. Okay, it's good I caught it now. Just turn my attention to replacing that. Okay, let's give this a try. I've wedged my tool up under one end of the component I'm after. I think it's this. May not be that. Let's try this one. There we go. sure I got it right out yet. No, it's still stuck. There we go. Now, with it lifted up like this, I can get a grip on it. Pull it out. It's this one. Ten microfarad, 6 volts, just like it says. Okay, I gotta find the replacement to stick in there. So I put the leads of the new capacitor into the holes. I got my finger holding it on the other side. Just a little bit of pressure. Push it through the holes when I melt the solder. There it comes. Okay, this one's actually through already. I didn't shape these. Didn't shape them properly. So I'm looking at the holes that it has to reach. Putting these little bends in it, making doubly sure I'm putting the polarity correct. Okay. Comes. Very good. Down. So maybe this is going to correct the poor sound. Okay, I'll get to listen to it again. Switch off. Okay. still going. Onto the antenna. Hello. Nobody. Nobody. What happened? Believe it or not, the power cord, you never know, popped out up here for some reason. Isn't that something? Just lucky I looked up there. Okay, let's try it again. Hey, come on. Okay, let's look up there again. Did something stupid. How about we put the red thing into the red thing? Yeah, there we go. Red thing and the red thing. Let's try it now. I think we have more volume. I think it still has kind of a hashy sound to it. It's got that funny buzz in there too, but I won't worry about the buzz. I think the buzz is just interference. Well, let's go after that diode that I had proposed right at the start. Let's see what happens with that. One leg out. Okay, let's see what we got. IT23. Hey, where's the G? You can see the band is on the long wire. That's what that would look like to me. The banded end is on the longer lead. Well, 1T23. Now, no question, that's what it is. It must just be a slightly modern version over the pictures we were looking at. 1T23. Let's see what we can find out about it technically. What kind of diode it is. I think it's germanium to begin with. Well, germanium diode. G, germanium. That's what that G has to be there. But the one I have doesn't have the G. Well, here's a 1T23. Looks more like the one I have in a sense. And I don't have these pieces on the end here. Let's just keep looking. 1T20 something. This looks much more like what I have. Still germanium. I think they're all going to be germanium. A germanium diode is a good choice for a detector. Oh my gosh, look at all these in here. Okay, right there, 1T23. Germanium. So they're all germanium. That's the main thing. Now, what about the ranking or rating of these things? This doesn't tell us anything about. It's not much of a rating. So I've been poking around through lots of diodes here. I got all kinds of them. A lot of these I'm not sure what they are. This is a small number of what I've actually got. Poorly organized, but I did find these. These turn out to be switching diodes. Look at how many I've got. There's a whole bunch of them there. $3. And these ones, 1N34A germanium diodes. These I think are your classic diodes you put in crystal radios, I think. I got a bunch more here. There's some interesting ones that aren't really labeled. So we're gonna try this. We're gonna try this guy. I took a look. He's takes very little forward current. This is probably why you find these in crystal radios. Yet can tolerate a fair bit. Reverse voltage, 50 volts or something like that. Quite a bit. Now, wait a second here. There's a whole sheet here. Why don't we read the sheet? These are parts I've acquired from various sources over the years. Sometimes yard sales and stuff like that. Sometimes, occasionally, people hand me stuff. I go, hey, we got this stuff from my uncle. I don't know what it is. Do you want it? I go, okay, I'll take it. AM/FM detectors, bingo. Ratio detectors, discriminators, TV audio detectors. So these find their way into detectors a lot, and I bet you again it's because of that very low features. Lower leakage current. I guess they mean reverse leakage current. Flat junction capacitance. So I guess it doesn't. The capacitance doesn't change with varying pressures, voltages, high mechanical strength, at least 1 million hours, something or other. And BKC's Sigma bond plating for problem-free solderability. Well, that sounds just great to me. Let's put one of these in, see what happens. That's a great idea. Now I got to figure out polarity and stuff like that. So, well, we can do it right here because we know the long band was on the long wire. There's the band. This would be the long wire. Put it in like this. Wire came over this way. So I think I mentioned at the very start, I don't work on transistor equipment very much, very often. So this is all kind of new adventures for me. Okay, let's get the soldering iron here. I figure somebody my age should be working on vacuum tube stuff and leave the transistor stuff to younger people. Even though when I went to college in the 70s, all I was taught was we weren't even taught transistors. Discrete transistors were already past. We were being taught about integrated circuits and other things. Transistors, tubes, no, not even mentioned when I was in college, of course. So I'm thinking, tube knowledge is somewhat limited. Of course, nothing's really limited knowledge-wise with the internet anymore. But there's only one way to get the experience someone like me has got, and that is to grow older. I've done that part, and so that's why I mostly stay away from transistor equipment. Now my shop was all outfitted for working on vacuum tube equipment, still is, parts and things like that. But in the meantime, I've actually acquired a substantial supply of components for doing transistor work too. Some of which you're seeing here, a little bit of which. Okay, new diode, maybe a new breath of life. I frankly think this won't make any difference. In fact, I think there's a chance this actually won't that I put a wrong kind of diode in here. But let's see. Let's see what happens. Okay, power supply is off, switch is off. Still going. Okay, power on here. And away we go. What do we get this time? I'm not sure what the hum is that comes in every time with it. Let's listen to the highs again. I'm gonna tune somebody in. We gotta hear something for real. Give me some real radio here. There's a voice in there. Sounds about the same to me. Still sounds, I mean, it's terrible, but I don't know if you can hear what they're discussing, but they're discussing the continuation of wearing masks. I think I mentioned my own personal view on this is we're going to be asked to wear masks for another year, certainly here in Canada, and I think Canadians will be willing to do it without too much fuss. I hope. Okay. Well, to me, this radio sounded exactly the same. It still has the same hashy sort of sound to it. So there's something more going on. Changing the diode, I think, made no difference at all. Not too surprising. The chances of this diode being bad are very, very low. But it's good to eliminate that possibility. Now, what might be next? So, it's possible alignment is part of the picture here. It doesn't quite sound that way to me. Maybe we need to scope the signal as it passes through the radio stage by stage and try to see where things go downhill. And then we know the problem is in that stage of the radio. We're just kind of shooting at things. I don't think there's much to be gained anymore, just doing random replacements or stuff like that. But it does work, and you could listen to it at this point if you really wanted to. With voices, I think would be, certainly not what it should sound like. Now, how do we know the speaker's good? Jim, how do you know that speaker's good? How do we know the speaker's good? Let's make that the last thing we check here. The last test here would be the speaker itself, which I should have done much earlier. Didn't I do it? I thought I did it. Didn't I do it? No. Okay, let's make sure the power's off here. No power. And we're going to feed basically that same whooping signal you were listening to into the speaker here. Where's a good spot to get on it? Right on the speaker terminals themselves. Okay, now my signal generator does not have much power, so it's not going to make a loud. I'm not going to be loud coming out of this. Turn it down, in fact. listen to the bass. Yeah. Speaker's fine. There's nothing wrong with the speaker. Should have done this test much earlier though, because I have been surprised by the kinds of distortions that can come out of a speaker. So, but not this one. So the problem is definitely in the radio. Well, I think that's it for today. I think today the weather is cloudy and humid outside, warm. And did you hear how hot it got out in Western Canada in one particular city? 115 degrees Fahrenheit. That's 49.5 Celsius in Canada. What are we going to do? Like, how's the snow going to come now? Oh my gosh, that's just terrible. That's unbearable. And that's probably coming this way. See you in the next video.